So today it's about permutations. Now, these are often confused with combinations. Like, in fact, the name of a lock that typically a high school kid uses to open their lockers, back in the day when kids actually used their lockers, there'd be 3 numbers on it, and you spin the thing right and then left and then back to the right again. I bet you some of you probably haven't even opened your locker this year. Did anybody actually use their locker this year? Yeah, 3 or 4 of you, okay. And others of you probably have never even seen where it is. So these locker combinations used to be like 3, 23, 4, or whatever. Does the order matter when you're putting in that? Yeah, if you put these in the other order, it doesn't work. So order matters on those. That's a permutation. But unfortunately for math teachers, they call it a combination lock. It is not. It is a permutation lock. Okay? A combination is something different. A combination is when you don't care what order the numbers are in. And you might think, well, there's never a situation where I don't care about the order. But there really is. Let's imagine that out of the 30 of you, I was going to pick 2 kids to, for instance, represent the class. Okay, the 2 that are going to be leaders. They're not the president and the vice president. They're just 2 representatives from the class. Then, if I have Bob and Susie, does it matter what order they're in? Susie, Bob, Bob, Susie, I don't care. So sometimes you don't care about the order. All right, let's say we all of you, and there's about 30 of you in the room right now, were to go out into the parking lot, line up on one end of the parking lot, and race. Would you care who finished first? Well, some of you might not be competitive, but if you're competitive, you care about what order you finished in. And if I had 30 of you run across the parking lot, and I care what order it is, I use a permutation. And let's say I only keep track of 3 places, first, second, and third. That would be a typical question. 30P3. That is a permutation because the order mattered. If it had been a combination, I would have used a C. If I didn't care what order they finished in, then that's a combination. Now, these are way bigger than you would think. 30P3, it's huge. I'm going to do the easiest one and just ask you this. What if I only cared about first place? I literally just cared about who was first. Can you do 30P1 in your head? Well, here's the question really. If 30 of you race and I only keep track of first place, how many different ways could it end? 30. You can do the P1s in your head because you're saying, I have 30 of you racing. How many different ways could it end? There's just only 30. But as soon as I make it 2 places, then it's like first place and second place. And all of a sudden it gets more complicated. Now this is the part where it's not going to be 30. 30P2 is not 30. I got, like for instance, Bob and Jim could finish Bob's first, Jim's second, or it could be Jim first and then Bob second. So that is different. And so you care about the order. And if there's 2 of them, it's much more complicated to do in your head. Isn't it just like double and make it 60? Well, let's do it on the calculator. Grab your graphing calculator because I'm going to show you how to do these on the calculator. If you don't have one of these, I strongly recommend you borrow one from me because the iPad can't even do it. And you won't have an iPad on the test. You'll have one of these. There you go. Anybody else want to borrow one? There you go. There you go. Okay. Now, how do you type this into the calculator? If you have like a Casio or something, I'm not going to even know how to put that in the calculator. All right? But if you've got the typical TI-84, then it's going to go like this. We're going to go under the Math button, and then there's a whole bunch of tabs across the top. One of them is called PRB. That stands for probability. So go to Math and then Probability, and then you're looking for a thing called NPR. All I'm asking you to do is find that spot. If you can put that on the screen of your calculator for now, that's good enough. NPR, it's under math key and PRB for probability. I'm gonna pause for a second. I'll make sure everybody can find NPR. So, did you find NPR? Now, the only question is if you are using an old calculator or a new calculator. I really wish, honestly, if I had to do, I would have made TI only have one operating system. So that is only one set of directions for everybody. So if I want to do 30p2, you either have to type the 30 first and then the NPR thing and then the 2, or if you got the new style calculator, it puts a little box right here and here, and you could just put the 30 and the 2 there, okay? Either way, would you put it in? If you don't have little boxes, put the 30 first, then put this. So many kids are like, they start with the NPR thing, and they're like, I can't put the number in front of it. Yeah, you're right, you can't. You got to start with the first number, so you got to type 30, then you got to type NPR, then you got to type 2, and then you hit enter. All right, if you need help, the kid right next to you can probably help you. But I'm going to walk around, and I'm going to ask you to hold out your calculator so I can see that you can do this, because if you can't, you won't be able to do your homework, and you won't be able to do your test questions. You have to know how to put these in a calculator. Okay, so there's a nice simple answer. If you and the kid next to you have the same answer, you probably did it right. I'm going to pause for a second while I walk around. So, I checked. Pretty much everybody has it. It's 800 and, help me, is it 70? 870. And that is a really big answer, and that's one of the things I want you to remember about permutations is they're way bigger than you would think. So, only picking out one kid out of 30 as the winner of the race, that's super easy. It's just going to be 30 different winners. But as soon as you move to 2 and you care about the order that they finish in, it's going to be way, way, way bigger. All right, so here's my favorite example of this. Would you agree that a typical school bus can fit 55 students? Have you ever seen that written on the side of it? Max capacity, 55. All right, so then you got 55. P, because the order you sit in can be observed, right? The order of the spot you sit in. Like if you sit in the very front spot, we can call that spot number 1, and there'd be 55 spots on the bus, okay? And if we have all the seats filled, that'd be 55P55. And that means the order, how many different orders you can sit in. Now don't type it in yet. I want you to just think for a second. I already warned you these are big answers, okay? But I just want you to picture a bus full of kids pulls up out there. It happens every morning. And they get off the bus. I know a lot of times kids sit in the same seats just out of habit, okay? But you realize that they could sit in a lot of different seats, right? Let's say that you just had to take all the kids on that bus just for an experiment one day and get on and off the bus until you did every single order possible. All right. Do you think that would be closer to take you 1 day, 1 week, 1 month, 1 year, 10 years? Know what the answer is? 3 lifetimes. I'll prove it to you. Let's say it takes 1 minute per each swap. Okay? Now, type in 55P55 and see how enormous number of ways you could sit on that bus. It does not seem possible. But human beings suck at permutations. You would have never picked 3 lifetimes out of that list I gave you. You'd have been like, no, 10 years seems ludicrous. All right. And I know it starts with 1 point something. Mr. Breen, could you tell me what it starts with?
1.269.
And then it says EE what?
73.
So I'm supposed to move this decimal over 73 spots. There's 3 spots. And I'm just going to add 3 more zeros and then 3 more zeros. And that means I've done 9. If I just move to there, I've done 9 out of my 73 spots, and I'm already at 1 billion. We don't even have a name for the number where you move over 73 spots. Okay, so if it was just 1 billion minutes, that's way more than your lifetime. So it's insane how long it would take to rearrange that. All right, Here's another one that blew my mind. You shuffle the deck of cards. It's got 52 cards in it. If you take the order of every single card, you just, you've got this order that they're all in. Looking through the decks for those on the video right now. So I'm just saying, if I memorize this order, that would be one order that they could be in. And if I move even one card from here to like back here, it's a new order. Okay? Well, wouldn't that be 52P52? All right. Go ahead and type that one in, 52P52. And then I want to talk about what that means about shuffling the deck. It's not as big as my bus problem, but how does it start? Ben, how does it start?
Result?
Yeah.
8.0658.17.
And that's good enough. And then EE what?
67.
I have to move this over 67 spots. It's like mind-boggling how big the answer would be. 67 spots. So somebody figured out that if you took every human on Earth, since cards were invented, 52 cards were invented at some point, and you took every human on Earth and had them shuffle different arrangements of the deck for their entire lifetime, and then they stop and their kids continue the shuffling process until the present day, we still haven't seen even close to all the different combinations. In fact, if I were to shuffle this deck of cards, like here, I'll just shuffle it right now, it's very likely that, just to keep it simple, it's very likely that this particular order, even with all the casinos shuffling all the decks of cards, that this particular order has never been seen before in the state of Minnesota. It's never been seen. Nobody's ever seen this order of the cards. It's extremely likely. Because there's so many. All right, so permutations, really big answers. Enough about that. Now, let's talk about when order matters like this and you have givens. Given changes it. You can't just do like 5P2 for all your problems. It would be so easy if you could. But you're in honors. We go farther than just the basics. All right, so what if I say there's 1, 2, 3, 4, 5, 6 of you in this row right here, okay? The 6 kids that are in this row right here in class. And I'm going to choose out 3 of them. Do you agree that that is 6P3? And I could have how many different arrangements? Well, you could type that in a calculator. Well, let's not even do it. It's just, it's some dumb answer. Who cares? But as soon as I say, given Ben has to be in this spot because he really likes that chair a lot, so I say, okay, Ben, you can have that spot. If Ben's going to be here, now how many different combinations are there? Actually, permutations is the right word because the order matters. All right, so the way you do it when there's blanks like this is you're saying, well, Ben has to be there. How many choices do I have for Ben's spot then? Do I really have 6 choices for that spot? No, I have 1 choice for that spot, and it's going to be Ben. And then you move to any of the other spots, like maybe this one, and you go, well, then how many choices do I have for that spot? And don't say 6. Why can't I say 6? Because Ben's not going to be sitting there. So how many choices do I have? 5. And then why isn't it just 5s for the rest of them? That's hard for a lot of kids. So I could have picked anybody for any of those spots, but once I did pick somebody for this spot, then now there isn't even 5 choices left. Because this spot's locked in and this spot's locked in. So now there's 4 choices, and then there's only 3 choices left for that spot. Now, what do you do with these? You go 5 times 4 times 1 times 3. You multiply your choices. All right, so let's just do it quick. What's 5 times 4 is 20, times 1 is still 20, times 3 is 60. There'd be 60 different ways. We could take you guys right here, the 6 in this row. 60 different ways that I could arrange you in 4 chairs that are up here if Ben has to be in chair number 3. All right, I know that's kind of a dumb example of Ben has to be in chair number 3. How about this? what if it's a set of 3 people and you're taking the picture of your 3 friends and your tall friend has to be in the middle, because if you've ever taken pictures before, if you have the tall person in the middle, it doesn't look as awkward as if the tall person is on the end. And so you're going to say, I'm going to put the tall person in the middle. All right? So you have 3 friends. You're going to take their picture, but the tall person has to be in the middle. That's a typical test question. Can you answer? 3 blanks. Because there was a given. You can't do 3P3 because there was a given. The tall person has to be in the middle. How many of you knew that I only had 1 choice in the middle? Raise your hand if you had that. Good. And then did you know there was 2 choices here? And then it feels weird, but there's only 1 choice for this last spot. There we go. 2 times 1 times 1. So that really means there's only 2 ways you could take that picture. And it kind of makes sense. Once your tall friend is here, you only have 2 kids left. And then you could either have them this way and this way or reverse it. Okay, so there's only 2 ways. All right. Now the typical question.
Does it matter if you swap the 2 and the 1 and the other corner?
Yes. So that's why we have 2 different choices. So let's give them names. This is going to be Sue, Bob, and Jim. Bob's the tall one. Okay. So it's either Sue, then Bob, then Jim, or gotta leave Bob in the middle, Jim and Sue. You get this way or this way are the 2 different ways. So the answer's, there's 2 ways. All right. So here's another scenario. There's a swim team, and they got 12 people on the team, and they're going to race, and they're going to keep track of first, second, and third. Why would that not be the right answer in a lot of cases in the real world? Why wouldn't the 12 people that could finish first, second, and third, the 3 places, what would throw this off? It's not really random, is it? Who's going to finish first? Wouldn't you know if you're on the swim team? There's probably some kid who's going to finish first because they were really, really, really good. Okay, maybe they're like going to nationals or something because they're amazing. So let's say it's a girls swim team and it's Julia is freaking amazing. She's like going to the Olympics. Okay, well then I'd make blanks because now it's more complicated. I can't just do this because I know Julia's going to finish first. There are 12 people on the team, but Julia's going to finish first. So now, please figure out the answer. How many different ways could they finish first, second, and third? A lot of times in honors, you have to use the blanks because we give you these givens. Because Julia's going to finish first. Remember, think of these as choices. For first place here, I'm going from left to right. For first place here, I only have 1 choice. It's going to be Julia. But then it could be 11 different people could finish here, and 10 different people could finish there. That make sense to you? All right. Now I got to show you ones where the things can repeat. See, humans can't repeat. You can't be in first place and second place. Like, you're either finished first or you finished second. You're not doing both. But in the real world, you can have numbers that repeat. For instance, on a license plate. Back in the day, I had a license plate that was kind of fun. It was FEZ 470. So, even one of my buddies from high school remembered it as the Fez 470. It was kind of easy one to remember. I loved it. Well, do you get that there was a lot of different license plate permutations because the order matters? Because see, if somebody has the license plate ZEF 470, that is different. You know what I mean? It's a different license plate because the order's changed and the order matters. Therefore, this is a P question. But we will use blanks because a lot of times on license plates, what you're doing is you're saying, how many different license plates could I possibly have? But, by the way, did you know they never use a W? If they use a W on your license plate as the first letter, it's called a whiskey plate. That means that you have gotten a DWI too many times, and they are marking your car with a W to say, hey, this person is somebody to watch out for. It's for the cops mostly. They can just look at that license plate and go, ooh, if that person's swerving around on the highway, we're going to pull them over because they have a whiskey plate. They have a W in the first letter. All right, so there's certain restrictions on these. There's other restrictions like, you're never going to have, well, I'm not going to write a dirty word on the board, but you can imagine 3-letter dirty words. Let your imagination run wild. There's certain words that you wouldn't want on your license plate that are 3-letter words, okay? Even if they're misspellings of bad words, you still don't want it on your license plate. So there's a lot of these combinations or permutations, technically, if the order matters, it's a permutation, that are disallowed. But if I just allowed everything, do you agree there'd be 26 choices for this first spot, 26 letters? And if I just allowed anything, there'd be 26 choices for that spot. But wait, didn't we just go down every time before? Why can you have 26, 26, 26? Because you could have the same 3 letters. You could have a license plate that was like EEE. Know what I'm saying? So they don't always go like 26, 25, 24. Because if you have letters, you could pick the same letter all 3 times. And how about the numbers? Is there really 9 number choices, 1 through 9? No, there's 10. Because you can have a 0. And what do you do to the choices? You multiply. All right. Now, how does this turn into probability? I thought we were in the Unicode probability, and we haven't even done a single probability all hour. The way it turns into a probability is this. Remember my FES 470 license plate? How many of them were there that were exactly like that? There was 2 FES 470s in the world? There's only one. There's only one. Out of how many? All of those multiplied. So what was the probability I was going to get that license plate? Well, there's only one of these. Out of, I don't know what that number is, but let me ask my computer. What is 26 times 26 times 26 times 10 times 10 times 10? 17576 000. In the end, all of your probabilities are what you want. It goes on top. And how many of them did I want? I only wanted that one license plate. That's what I was investigating, the probability of getting that exact license plate. Out of how many possible plates were there? 17 million. How come we have to have so many license plates? Because everybody in Minnesota could have a car. And in fact, the average person in Minnesota has more than one car. Yep. That sounds crazy, but there's a lot of people that have like 3 cars. And that throws off the average. So you have to have enough plates. So you have to have millions and millions of permutations or combinations. What are we doing today? Permutations, because the order matters. Remember, if I rearrange the order, it's a different plate. It's called a permutation. All right, cool. You've done enough now where you maybe don't totally understand this, but you got enough where you can start the homework. Your assignment is to do the worksheet that's there, except you can skip the last problem. I'm giving you significantly more time than I did last hour. I think I went on with kind of fun real-world examples a little too long. So they got to skip an extra homework question because I literally only gave them 5 minutes to do homework. You have about 25 minutes to do homework. All right, so you get to skip just the last question. All right, here we go. Number 1. And 8 volume, ooh, is it just gonna be 8P something? Yeah, it might be. 8P what? Well, how many books are you gonna take out of your collection of 8? You're gonna take all 8. 8P8. And you might think that that's 1. It's not. The question is, how many different ways could you arrange those books? So every time you rearrange them, that's a new order. Of course, there's not just one way to put those books out. The order matters. So it's 8P8, and it's some really big number. Quan, can you tell me what you got for 8P8? 40,300? 320? That's different. 40,320, can you guys agree on that one? Yes? All right, good. Okay, now is that a probability? No, it's just how many different ways can you do it? All of a sudden there's a given. What do? Use blanks. There's 8 choices. How many choices do we have for the very first book? Hint, it's not 8 because of the given. They said volume 5 cannot be there. Volume 5 has to be there. So there's only 7 choices for this book. And then 6 choices, and then 5, and then 4, and then 3, and then 2, and then 1. I know it feels weird. A lot of people are like, but wait a minute. 1, 2, 3, 4, 5, 6. That's only 7 books. Sorry. What about this last spot? Remember, it's choices. How many choices do you have for the rightmost book? 1 choice. So you'll have another 1 there. It's kind of like this. You put this one out first, it's got to be there. The volume 5 has to be the last book. I have 1 choice for that. And then you go, oh, I only got 7 books left. Now I got 6 books left. Now I got 5. Now I got 4. Now I got 3. Now I got 2. I only have 1 book left. And you multiply them all up. Now this is going to be 50,000 and something. You can do math. You use your calculator. And then this one wants you to do a probability, which is the 40,320 was the bottom of it. Dang it. That goes on the bottom. Because that's what it's possible. Do you remember me keep coming back to what I want goes on top and what's possible goes on the bottom? The 40,320 was what was possible. What I wanted was to have volume 5 as the rightmost book, and there's less of those. I think it's 5,000 and something, but you'll figure it out. Then you divide them and you get your answer that way. All right. Now, you're going to use blanks for almost all the questions. Only the super easy ones can be done with like 8P8. Tomorrow we're going to do combinations, which will be similar, of course, except it'll be a C instead of a P, and the answers are smaller because the order doesn't matter. All right. That's all I got for you for today.